Welcome. In this video, we're going to continue our exploration of integration by parts. And I'm going to teach you a new technique that involves using a table for integration by parts. But before I introduce that technique, let's demonstrate what happens if I just apply integration by parts in the traditional way to this integral. And if you're following along in my course, in my Canvas course, pay special attention. This is the same integral from the clip and stand and deliver at the beginning of this module. Okay, so let's go about applying parts the standard way. So let's let u equal x squared and dv equal sine x dx. Then du equals 2x dx and v is equal to negative cosine x. So now I can rewrite this as negative x squared cosine x minus the integral of 2x times negative cosine x dx. Now this can be simplified. So let me scooch this over and write this as negative x squared cosine x plus 2 times the integral of x cosine x dx. Now you have already seen this integral. It was one of the first examples in this module, but let's say you haven't. We need to apply integration by parts again in order to solve this. So now I'm going to let u2 equal x, dv2 equal cosine x dx, du2 equals dx, and v2 equals sine x. So now I'm going to rewrite this, since that hasn't changed, negative x squared cosine of x. Then I'm going to add 2 times whatever this integral is using parts. And to review, we're going to multiply these diagonally across. So this is x times sine x minus the integral. And to get this integral, we're going to multiply this bottom row, so dx and sine x. And so this is negative x squared cosine x plus 2x sine x minus, and then the integral of positive sine x is negative cosine x, and I have a negative up front, so I'm going to make that into a positive, and then I have to remember to distribute this 2. Then I have to remember to distribute this 2, so that gives me 2 cosine x plus c. Now, while for this example, it might still seem doable to apply integration by parts twice, what if I had given you the integral of x to the 5th sine x? Or something with some higher power. You'd have to apply parts over and over and over again and keep track of what you're multiplying by something else over and over again, and that takes a lot of work. This is where tabular integration can come in handy. All right, so to make our table, we're going to put our u in the left column and our dv in the right column. And I chose x squared for u. And if you're following along in my Canvas course, I still haven't gotten to why I'm choosing these values for u, but we'll get to that. And then here, I'm going to say sine x is my dv. So on this column, you're going to take derivatives. And on this column here, you're going to integrate. Okay, so the derivative of x squared. So the derivative of x squared is 2x. And the derivative of 2x is 2. And the derivative of 2 is just 0. So now I know where to stop. Since I have a 0 here, I know where to stop. That should give you a hint that this method only works when the choice of u has an nth derivative that is 0. All right, so now let's go ahead and integrate. The integral of sine x is negative cosine x. The integral of negative cosine is negative sine x. And the integral of negative sine is cosine x. Now there is one last thing to do on my table, and I'm out of space, so let me just do this right here. I'm going to put a plus sign first, then a minus, then a plus. And then I want to reiterate, eventually the derivative of u, which was x squared, became 0. This tells me where I stop, so I keep finding the antiderivative of my choice for dv until I reach this row with a 0. And then I'm just going to put plus, minus, plus. And I skipped this first box here. That should just stay blank. So here's the spot where I took my first derivative and where I found my first integral, and I put a plus there. All right, so what do we do with this? So I'm going to circle x squared and draw a line diagonally down to cosine, negative cosine, and then straight to the positive. I'm going to do the same thing with 2x, circle negative sine of x, and then circle that negative sign. Finally, I have 2. Let's draw the diagonal down to cosine x and then the positive. And let's see what we end up with. Multiplying these values circled in orange produces negative x squared cosine x. Multiplying these purple values, that's 2x times a negative sine x times a negative, gives us positive 2x sine x. And then multiplying this 2 times cosine times a positive gives us 2 cosine x. And of course, let's not forget our plus c. Hopefully you can take from this that integration by parts using a table can be a lot easier. You will end up with the same answer, and you don't have to do parts multiple times as we did here, which involved tracking 2 times, again, the integral here, which was done by parts. Now, if you're going to use this method, it only works if your choice of u has an nth derivative of 0. I hope this video was helpful.